Okay, guys, on to 5.5. Like we mentioned earlier, I'm going to use some of chapter 5 in chapter 2 because we're talking about some basic derivative rules, and this kind of meshes well. As we go through today, don't forget about this idea of change of base. Do you guys remember this from pre-calc? If we can change the base to be anything we want, we're going to want it to be natural log. So we can rewrite this as you take log of this number on top and then natural log of the a, which is the base on the bottom. And really you could change it to be anything. So I could make it log base 5 of x over log base a. I'm sorry, over log base 5 of a. What we're doing instead is we're making it log base e of x over log base e of a. Okay, so we wouldn't want to use base 5 because that's not like a common log that we would use. So we like natural log in calculus, and I'll show you why as we go through this. Okay, so our rules that we're going to memorize today. So we're going to keep this in mind, but if you take the derivative of a to the x, you copy it over, and then you multiply by the natural log of the base. Think about what we did before. So going back, if you guys took the derivative of e to the x, if you follow this rule, doesn't it say, this rule right here says copy a to the x over, and that's really what we did with e to the x. Now this rule is saying also take the natural log of a, which is natural log of the base. Well, if we apply that to this, isn't that natural log of the base, and the base in this case is e? But what's natural log of e? It's 1, and that's how we got this rule. So this new rule that we're learning right here actually applies to what we learned already, but now because we have a different base a, we have to write natural log of a. Okay, you're going to do the same thing on the right, except now you'll see chain rule. So if it says u is a differentiable function of x, just like we looked at before. So we're going to use chain rule. So u is part of the chain. So because of that, we're going to use a similar formula. You rewrite this right here, take natural log of the base, and then now we also have to multiply by the derivative of the exponent. We technically did it here, but what is the derivative of x? It's a 1, and we don't need it. Okay, so again, chain rule, you can see how it matches up. The other rule that we're going to look at today is right here. If you take the derivative of log base a of x, and this is really, guys, just pure memorization, this guy goes on the bottom, and you multiply by the, you divide by natural log of a. Over here, to take the derivative, now it's with chain rule, u is a function of x. You take u and throw it on the bottom, just like we threw x on the bottom. You divide by natural log of a, just like we divided by natural log of a. But because it's chain, just like up here, we had to multiply by the derivative of the exponent. Now we're going to multiply by that derivative. Okay, so for some reason, I am awesome at memorizing this. This one gives me pause, so I have to think of another way. I'm going to show you the proofs of both so that you can see why they work. Okay, the first one. Let's keep that box up here. So let's prove why the derivative of a to the x is natural log of a times a to the x. Okay, well, let's say we are given a function that looks like the thing that we want to take the derivative of. Okay, so let's say we are given y equals a to the x. Okay, let's separate this. So if we are given y equals a to the x, and you know what, let's box this off too. Okay, so we're given y equals a to the x. Let's take the natural log of both sides. Doing so allows this x to come down in front. Okay, so now that we have this, let's take the derivative of both sides. Okay, now y right here, to take the derivative of y, do you guys remember how to take the derivative of anything involving natural log? That thing goes on the bottom, and its derivative goes up top. Now over here, this right here is just a number. So what's the derivative of a number times x? Like, what's the derivative of 5x? It's just 5. So what's the derivative of natural log a times x? It's just natural log of a. Now we're almost done, but we're trying to find the derivative. So now can't we, let's put a little separator in here. I'm going to take this function over here, and I'm going to multiply both sides by y to get the derivative by itself. So now y prime equals y ln a. But look back up in the beginning. What was y equal to? Y is equal to a to the x. So now I have a to the x times natural log of a, and we are done. Look at what we just proved. This is exactly what the derivative is. Okay, now would we want to go through all of this work when we could just memorize this? Not at all. So if you take the derivative of a to the x, copy it over natural log of the base, and then if this is a function, if u is a function of x, also multiply by the derivative of the exponent. Okay, now for this next one, I told you earlier on that I don't intuitively memorize this. So if I think of change of base, it makes a little more sense to me. So if we, in this problem, if we're trying to prove the second rule, so the derivative of log base a of x, we're trying to prove that it's 1 over ln of a times x. Okay, so that's what we're trying to show here. In order to do that, let's rewrite the thing that we were given, which is y equals log base a, and look back up at the top here at this change of base. We're going to write it as ln of the big over ln of the small. That's really not mathy, but just think of the big number, right? And then the base goes on the bottom. Think of it that way, base, bottom. Okay, base, bottom. So we are going to use change of base. So it's going to be natural log of x over natural log of a. Change of base. I'm going to rewrite it again. I'm not using calculus, but remember natural log of a is a number. So I have 1 over natural log of a times natural log of x. So if I go to take the derivative now, this is a scalar which stays in front, and the derivative of natural log of x is 1 over x, and ta-da, we just did our proof. Okay, so let's cross this off, and y prime is 1 over x ln a. If you look up above, that is the derivative. Where am I at? 1 over x ln a. Okay, so that's why they work. In case you were interested, again, I memorized this. In order to do this derivative, I just quickly rewrite it as change of base and then go forward. Okay, let's look at example 1 now. Find the derivative. I'm going to do it two ways. I'm going to do one with the formula and one with change of base, okay? And then you guys can choose what you like. It really doesn't matter to me, whatever helps you to learn. Okay, when we have logs, natural logs, we always have to expand. So we are going to expand this to be log base 4 of 2x minus 3 minus log base 4 of x cubed. And actually, how about we take that cube and take it down in front, and that can be our coefficient. The reason we want to do this, it's going to be so much easier when we go to apply the derivatives. If you guys were to leave it like this, you then, when you go to take the derivative of this stuff using chain rule, you have to use quotient. And you see now we don't. Okay, if that's not clear, let me know in class. Okay, so step 1, we are going to use the formula. Okay, so to use the formula, if you look up above, you can see it. It says to write natural log of a in the bottom. So natural log of the base, we have a natural log of 4. Then it says to write u in the bottom. This is my u. So 2x minus 3 goes in the bottom. Then it says the top is u prime, so it's the derivative of what I just wrote here, which is a 2. Minus, there's a 3, because it's our coefficient right here. It says to write natural log of 4 on the bottom. Then it says whatever you're taking the log of, which in this case is an x, to put that on the bottom, and the derivative of x up top is a 1. Okay, so we are done with calculus, guys. Now it's just algebra. You have to get common denominators. So I'm going to multiply, just within the problem I'm going to do this. I'm going to multiply this by x over x, and this other side needs a 2x minus 3 and a 2x minus 3. So now my numerator is going to be 2x minus 6x plus 9 all over x natural log of 4 and then 2x minus 3. Okay, so that's using the formula. We actually have to rewrite the top, combine some like terms. Okay. If you don't like memorizing formulas, you could use change of base. So I'm going to take this expanded thing right here. So I'm doing the same problem another way, and I'm going to use change of base. So if I'm not a fan of anything that's not base e, then I'm going to rewrite this. So this first part is going to be natural log of 2x minus 3 over natural log of the base. Remember, base bottom. So it's natural log of 2x minus 3 over natural log of 4. The next one is 3 is a coefficient, and then it's natural log of x over natural log of 4. So by doing this, I no longer have to memorize this formula that told me how to take the derivative of base 4. Now I'm just going to use base e. Okay, so now the derivative, natural log of 4 is just a scalar. Remember, when you take the derivative of anything natural log, whatever follows the natural log goes on the bottom and its derivative goes up top. Minus 3 and natural log of 4 are scalars. Again, whatever you take the natural log of, that thing goes on the bottom and its derivative goes up top. Now look, I'm exactly where I was back in this step in the beginning. They look the same. Now I just have to get common denominators. So I'm going to multiply this side by 2x minus 3. I'm going to multiply this side by x. So now my next answer is going to be 2x minus 6x. Again, we already did this, so if you guys are catching on, you can just write the answer. You already saw it to the other side. Giving you negative 4x plus 9 over ln 4x 2x minus 3. Okay, two ways to do these. Again, if you like memorizing formulas, number 1, change of base, number 2. Okay, going on, now we have this one. So this is more like, let me see how I numbered them. This is more like number 3, the way that we have the formulas written on page 1. So what this one says to do is copy this over, take natural log of the base, so natural log of 4, and then because this is chain rule, because it's not just to the x, but because it's to a function of x, we now have to multiply by the derivative, which is 3. Okay, so then we can rewrite this 3 ln 4 times 4 to the 3x. Okay, going on to C. So today, there's not a lot of concepts, just a lot of working through these. Remember, you guys always want to rewrite this. So how we can rewrite this, remember with trig, we always want to write it as sine x squared. Now, whenever we have log and following it, we have something squared, that 2 can come down in front. So now I get 2 log base 7 of sine x. Again, we have a log that's other than e, so we're going to do the two ways. The one is with the formula, and the other was with change of base. You obviously don't have to do both. It's whatever you want. Okay, on this, 2 is a scalar. Because we have log base 7 here, we're going to write natural log of 7 in the denominator. And then whatever follows, so this thing goes in the denominator, and that derivative goes up top. Now you could rewrite this. Isn't cosine over sine cotangent? So we could do this. Okay, again, if you find that you're having issues and you don't know where this goes with the formula, if you forget to put it on the bottom, change of base is a good alternative. So what you do first is you copy the problem over, and it's going to be 2 is our scalar, and then it's natural log of whatever follows the log, so in this case sine, over natural log of the base, which is 7. So now when I go to take this derivative, 2 natural log 7 is my scalar. Whatever you take the natural log of, let's see right here, whatever you take the natural log of, that goes in the denominator, and the derivative goes up top. And then, just like we did before, you could rewrite this as 2 cotangent x over natural log of 7. Again, I did both ways. You guys pick. Okay, D is a lot like B, where we have a base other than e, but we treat it just like that. So remember, the derivative of e to the x was e to the x. The derivative of e to the u was e to the u times u prime. Now, in addition to that, we just have to multiply by a natural log of the base, which was e, and that's why we didn't need it. But now we will need it because we no longer have e, we have a 6. Okay, I hope that was clear. If you need me to explain that part again, how 6 to the negative 2x is similar to e to the negative 2x, let me know. Okay, so the derivative. First, to take the derivative, you copy it over. You take the natural log of the base, which is 6, times, this is chain rule, times that derivative of the exponent, which is negative 2, plus the second, which is 6, negative 2x, and the derivative of x is 1. You totally don't need that 1. I just want to remind you about it. So in this case, our first was x, and our second was 6 to the negative 2x. Okay, now if you look at both of these, we have two parts here. Remember, I want you to think of this addition sign as really separating them, and you want to say, what do they have in common? Do you guys see that they have a 6 to the negative 2x in common? So what's left in this first grouping? We're going to have a negative 2 natural log of 6 times x plus 1, and we're done. Okay, kids, almost done with this. Again, a shorter lesson because it's just some new rules. Okay, what do these guys have in common? See if you can find out what it is. Hit pause because I'm going to tell you if you didn't think of it. They have an x in the base and an x in the exponent. So this we have to approach differently. This is going to be logarithmic differentiation. Trying to squeeze that in. Okay, so what we have to do here is we want to bring that x out of the exponent. So we are going to rewrite this as y, and we are going to take the natural log of both sides. What this does is it allows us to bring this 2x down in front. Okay, now that we have this, we're going to go ahead and apply the derivative. So let's write that we're going to take the derivative of both sides. That awesome operator. I know this is looking a little messy. I bet you're seeing product rule. Okay, so whatever you take the derivative of, that thing goes on the bottom, and its derivative goes up top. Now on the right, that 2 is a scalar. I like writing it out in front and dealing with it at the end. So in this case, because of product rule, our first is x, and our second is natural log of sine x. Okay, so if we do product rule, it's first. Now, how do you take the derivative of natural log of anything? That thing goes on the bottom, and its derivative goes up top. Plus the second, which is natural log of sine x, and what's the derivative of x, which is the first? That's 1. Now, we're almost done. I wanted y prime, but there's a y here. So I'm going to multiply both sides by y. So now I get y prime equals 2y. Cosine over sine is cotangent, plus natural log of sine x. Did you guys catch this little typo here? It looks like I put an x right here, and I just want it to be natural log of sine, not natural log of x sine x. Okay, double check. Let's make sure this looks beautiful. It's looking good. So now that we don't want y in our answer, but if you remember up above, here is what y is. So now I can replace this y with sine x to the 2x, x cotangent x plus natural log of sine x. Wow, so that looked bad. I don't think it was as bad though, because our only derivative was natural log, and we're so good at that. Okay, last one. If we can finish in 50 seconds, it'll be under 20 minutes. Okay, natural log of both sides. You guys try this one on your own. Careful with this. It's x e to the x. Now, the reason we did that is to bring the exponent down. So our exponent is this thing, and that can come down. So now we have e to the x natural log of x. Now I'm going to apply the operator. So d over dx, natural log of y, d over dx, e to the x natural log of x. On the left, remember, whatever you take the natural log of, that thing goes on the bottom, and its derivative goes up top. On the right, we're using product rule. The first is e to the x, and the second is ln x. So if I use product rule, oh, we just went over 20 minutes. We missed it. Okay, so it's first derivative of the second plus second derivative of the first. Now again, we don't want this y here, so we're going to multiply both sides by y because we're supposed to find y prime. Now we get y prime equals, you know what, let me go back. When I multiply by y, I want to make sure you know the whole thing gets multiplied by y. Okay, we're going to replace y with what it is, which is x e to the x, and then we have e to the x over x plus e to the x ln x. Let's see, did we miss anything? Oh, I do see one thing. Do you guys see something? This can factor out. We can take out e to the x. And then I'm left with 1 over x plus natural log of x. And actually, y prime works here. If we want to go back over here, they actually asked for g prime on the left. Okay, so now we are done with all of our log rules. Okay, don't forget you can use change of base up here like I did if you want to instead of the formula. Totally your call. This is what I prefer. Really doesn't matter as long as you get it right. Okay, see you guys.